In this video tutorial, we're going to see how to install QDrill and use it within the IBM SPSS Modeler. QDrill is an extension to Apache and it gives it analytics capabilities so that you can run machine learning algorithms within the SQL statements of Apache Drill. The tools you're going to need are the QDrill, which is based on Apache Drill 1.2 and Weka 3.7.13, which can be downloaded from this website. The QDrill Modeler custom node found on the same website, the MapR Drill RODBC driver, the IBM SPSS Modeler 18, and there's a 30-day free trial version. The SPSS Modeler are essential because we're going to connect to R in order to use QDrill from Modern Modeler. R 3.2.1, and that's very important. So Modeler 18, the version is very important, and it only works with R version 3.2.1. So you can download it from this URL as well. And finally, the RODBC package from within R. So it's very simple to install. You just open R and then type the command install.packages RODBC. So the first step is to download QDrill. So you can go to the URL here and then go to the download page, and then you can download from the latest stable release right here. It will download the tar file, and then basically all you need to do is untarring that file, and this will create the Apache Drill 1.2 folder in here. To run QDrill, then you need to go to bin and then open a command prompt, cmd, and then you go to that URL, and then you need to run the SQL line, which is basically the tool where you can do SQL statements from within the command line. And the command for this is basically SQL line -u JDBC drill schema equals DFS root, and for the zookeeper we're going to use the local because we're running this on our local machine, and the username is admin and the password is admin. We hit enter and we wait for a minute, and we'll be able to run our queries right away. If you're running Linux, then it's a little bit different. So instead of running this command, then you'll need to run another command, which is basically /drillbit.sh and then start. This will start the server, and then if you want to open the command line SQL interface, then you need to type the .drillconf, and this will give you the same exact interface as the one we're having right now on Windows. So now we have this interface, and we can use Apache Drill now to submit our queries. So let's first see what is Apache Drill. So once the server starts, you can direct your web browser to localhost and then port 8047, and this would open the web interface for Apache Drill. And here you can see how many drill bits are running. You can see which ports are being used, how much memory is available, and then what I want to show you is the storage right here. So in the storage, there are some predefined storage by default, and basically CP stands for class path, DFS stands for distributed file system, Mongo for MongoDB database, HBase for HBase, and Hive for Hive. And basically you can enable and disable them based on your needs. In this example, we're interested in DFS, so distributed file system. So if you click on update, then you can see the details of the storage plugin. Since I'm running on my local computer, so I don't have HDF installed, so I'm just using the file system. That's why we have the connection equals file. And as you can see, we have two directories defined here, two workspaces. So the root, which is not like you cannot write there, and the temp, which basically you can write and read files from. And there's also some formats defined. So there are lots of formats. One of them is CSV, and this tells Apache Drill how to read it. So basically CSV is separated by commas, and like this other extension is separated by the pipe, and so on. on. And with QDrill, we introduced a new storage model, which is right here, and this allows us to save binary Weka models and read them from whatever storage you're using, whether it's the local file system, distributed file system, whatever that is. There's also support for Parquet and JSON. If you're using HDFS, then all what you need to change is basically only one simple configuration, which is the connection. So instead of having a file here, then you replace it with your URL to your HDFS server, basically. So this is the IP of your HDFS, and this is the port for your HDFS. Okay, and then you just hit the update button. Same thing for Mongo. So if you're using MongoDB, then you need to just set up your Mongo URL right here. Okay, so now the server is up and running, and we have our storage. So let's see a simple example where we use the iris data in order to use the iris data for a classification problem. So we're gonna build a neural network on the iris data, and then we're gonna do some scoring on it as well in a distributed fashion with multiple threads on this local machine. So I have all my data. This is the /temp folder. So basically all our data, anything you want to analyze using Apache Drill or QDrill should exist in this folder if you're running on Windows on a single machine. So here I have the irisdata.csv, so I'm going to open it now. So basically it's just like 5 columns. The first 4 columns are the attributes, and the fifth column is the label. And here we have 3 classes, class 3 and class 2 and a class 1. Okay, so we're just gonna build a classifier using your networks, and then use that classifier for predicting what type of flower that one is. Okay. So basically, let's open our QDrill interface. So the first step is switching to the temp workspace. So use dfs.temp. So this basically tells Apache Drill to switch to the temp workspace in the distributed file system. It usually, when it starts, takes a little while, but then it's really fast. Okay, now we can here select all from iris.data.csv, and you need to put the name of the file in these quotes, which is basically because the file name has dots in it. And then if we hit enter, so basically this is just going to display the content of that file. And as you can see here, it basically grouped everything into a single column. And if you want to split them, then we can use the column attribute defined by Apache Drill, and we can do this. So select columns 0, columns 1, columns 2 and 3 and 4 from irisdata.csv, and this basically split the data into a number of columns. You can give them name as well using the as. So I can just do something like this, as class, and this basically will give the last attribute the name class. Okay, so now we want to train a neural network using some training data from the iris dataset, and then use that neural network for testing. So the first thing we need to switch our store format to the model format, the one introduced in QDrill, in order to be able to save the Weka models to the file system using our solution. So that basically a single command, alter session, and then you set the store.format to model to tell QDrill to use the model format in order to save the data. So now the format is updated, and now we need to train the neural network. So I know it looks like a lot, but it's very simple. So it starts with train model. So that's to tell QDrill that you're going to train a model now, and then ANN iris, this is the name of your model, and then as select QDM ensemble Weka. So this tells QDrill that you want to run in parallel in order to generate the neural network faster. And then from QDM ensemble weka, and then here you specify that you want to use the multi-layer perceptron, the neural network. You can replace this with naive Bayes, you can replace it with decision tree, you can replace it with whatever algorithm, weka algorithm you want to use. And then here you specify the classes. So here, like in this data set, we have classes like 3 types of flowers, flower number 1 and 2 and 3. And then you give it the data, so my data.columns, and then you use the RODBC algorithm in order to distribute the data among multiple threads and make sure that each of these threads are going to produce a well-trained classifier. So basically here 3, this represents the number of threads you want to use. You can have more threads. This will speed up the training, but it might affect the accuracy of your model. It depends on the amount of data you have. So if you have lots of data, you can have large number of threads. If you have a small data set, like in our case, then a small number of threads is recommended. And then here we specify the name of the data set, iris.data.csv, and then we hit enter. And voila, now we have a model. And basically, if you go to the temp folder, the one where the data is, you'll find that a new folder has been created, the NN iris, which is the name of the model you just trained. And if you go in there, you'll find 00.0.model, and this basically is the weka model. So if you edit here, this is the binary file representing the weka model. You can just import it into weka and use it for scoring from within weka or from within your Java program or whatever. And okay, so now we have a model. So let's use that model in order to do some scoring. Okay, so now to do some scoring, we're gonna use QDrill one more time in order to do that scoring. So select data to column. So now I want to display the columns of the testing data, and then I'm gonna use the QDrill QDM score weka function in order to ask QDrill to do the scoring. And then here I'm going to specify that my classes are 1, 2, and 3, and use my model and my data as prediction. I'm going to name this column as prediction, and then I'm going to specify where the testing data exists. So it exists in iris.testdata.csv. It's another CSV file in the temp folder as well. So if I go back to the temp folder, you can find here that I have iris data and iris test data. And then I'm going to apply, so I'm using the QDrill new keyword applying, and then I'm going to specify the name of the model that I just trained in the previous step. So now I'm going to use the NN iris model in order to score the data that exists in this iris.testdata.csv. I hit enter. And the testing data are here. So basically these are the data, the testing data, and these are the predictions. If you look at the last column here, so this is the actual values and this is the predictions. So it's actually pretty accurate in here. So I think it's like 100% accuracy. So this is basically QDrill using the command line in order to submit your SQL queries. QDrill introduces new functionalities, data mining functionalities to the existing Apache Drill, and make use of the distributed nature of Apache Drill to distribute the processing of the analytics as well.